Welcome to Still Science Lab. Tonight, we explore about where does light actually get its speed from? It is a phenomenon that fills every room you have ever stood in. It is the quiet, invisible messenger that lets you read words on a page. And it is the ancient radiation that travels from distant stars, crossing the unimaginable depths of the cosmos to arrive into your eyes every single night. Yet, despite its absolute ubiquity, it is something so deeply familiar that most people never stop to question it. We accept it as a given parameter of our waking world. But tonight, we are going to push past the illusion of the ordinary and ask the question almost nobody asks. Why does light move at the exact speed it does? Why not faster or slower? Why does the universe strictly enforce a speed limit of precisely 299,792,458 meters per second? This is not just a random measurement. This is a number so incredibly precise, so fundamentally embedded in the deep architecture of reality, that physicists now use it to define the meter itself. Where did that specific, unyielding number come from? What is it about the silent, invisible fabric of the universe that makes the speed of light exactly what it is, and not something else entirely? This is the central mystery of our physical existence. By the end of this journey, you are going to understand exactly where light gets its speed from, why nothing in the entire universe can catch up to it, and why the ultimate answer isn't really about light at all. It is about the hidden, governing structure of reality itself. To truly grasp the nature of light and the origin of its absolute speed limit, we must first pull back from light for a moment and look at something seemingly completely different. We must think about electricity. When you walk into a dark room and flip a light switch, the bulb turns on almost instantly. Your human intuition, heavily biased by a lifetime of macroscopic observation, naturally assumes that something physical must have sprinted rapidly from the switch to the ceiling. It feels, intuitively, like the electricity is moving incredibly fast. But when we peer into the microscopic reality of that copper wire, that is not quite what is happening. The electrons in the wire, the actual, physical, charged particles themselves, barely move at all. They drift through the dense atomic lattice of the copper at a snail-like pace, moving at a speed of only about 1 millimeter per second. They are crawling in the dark, slower than a glacier. So, if the particles are barely moving, what is traveling so extraordinarily fast? What actually causes the bulb to ignite the exact moment your finger presses the switch? What travels fast is the electromagnetic disturbance. It is an invisible wave of electrical pushing and pulling that rapidly propagates through the wire, carrying the raw energy from the source directly to the bulb. And that invisible wave of force moves at a large fraction of the speed of light. Hold that haunting image in your mind. A wave moving through a medium. Because understanding the true nature of the speed of light fundamentally requires you to think in waves first, and to think incredibly carefully about what exactly those waves are moving through. To find the origins of this cosmic wave, we must journey back to the middle of the 19th century. It was a time when our understanding of the universe was heavily fractured. Almost everyone in the scientific community thought that electricity and magnetism were completely separate phenomena. On the surface of reality, they seemed entirely unrelated to one another. Electricity was a violent, erratic world of charges, moving currents, and sudden sparks. Magnetism, on the other hand, was a quiet, mysterious world of compass needles, shifting iron filings, and natural lodestones. And yet, despite their apparent differences, experimental laboratories across Europe kept uncovering strange, undeniable evidence that they were deeply, inextricably connected. The physical world was offering up a profound secret. If you move a wire through a magnetic field, you get a current flowing through that wire. Conversely, if you run a current through a wire, you create a magnetic field that physically curls around it. The clues were scattered everywhere in the dark. In 1820, the Danish physicist Hans Christian Ørsted first noticed this hidden connection when a compass needle suddenly deflected as he passed a current through a nearby wire, an event that happened right in front of a lecture hall full of observant students. That single, brilliant accident fundamentally changed the trajectory of physics. Soon after, the French physicist André-Marie Ampère mathematically described exactly how currents produce magnetic fields, developing his equations in the early 1820s with extraordinary speed and precision. Then came the English experimentalist Michael Faraday, who showed exactly how changing magnetic fields create electric fields, definitively demonstrating the principle of electromagnetic induction in 1831 through a series of elegant tabletop experiments using simple coils and heavy magnets. All of these mysterious, invisible phenomena were being meticulously catalogued, painstakingly measured, and slowly connected by brilliant researchers across Europe throughout the first half of the 19th century. They were accumulating the puzzle pieces of the cosmos. But nobody had written them all down as a single, unified mathematical system. Nobody had created a coherent framework that captured all of electricity and all of magnetism together in one place. That is, until a Scottish physicist named James Clerk Maxwell sat down in the quiet of his study to unify them. Between the years 1861 and 1865, Maxwell accomplished something so profound that it would alter the trajectory of human knowledge forever. He published a set of equations, just 4 incredibly compact mathematical statements that managed to describe absolutely everything electricity and magnetism could possibly do. Every electric field, every magnetic field, every complex interaction between the two, every wave, every force, every instance of induction, every capacitor, every transformer, and every electromagnet ever built or imagined by the human mind was now governed entirely by those 4 beautiful, compact mathematical statements. But Maxwell did not stop at simply organizing the known universe into neat equations. He did something that changed physics forever. He looked deeply at what those 4 equations implied when you combined them, and he began to search for wave-like solutions hiding within the math. The mathematics revealed a stunning, hidden mechanics to the void. When you have a changing electric field, it creates a changing magnetic field. When you have a changing magnetic field, it creates a changing electric field. Maxwell realized that these 2 intertwined changes could feed each other indefinitely. An oscillating electric field produces an oscillating magnetic field, which in turn produces an oscillating electric field, which produces an oscillating magnetic field, carrying on and on across the vast, empty expanses of space. This was a self-sustaining oscillation. It was a ripple in the very fabric of reality, propagating through open space without the need for any physical wire, without any material medium, and without anything physical to carry the wave except the fields themselves. It was a wave made purely of force. Maxwell worked out the precise mathematics of that theoretical wave with great care. He wanted to know exactly how fast this invisible, self-sustaining phantom would propagate through the vacuum of space. To calculate this cosmic speed, he used only 2 constants. These were not astronomical numbers gathered from staring at the distant stars. They were terrestrial numbers, constants that had already been carefully measured in laboratories, entirely independently of any prior work on light or optics. The first constant described exactly how strongly electric fields form in a vacuum, a highly specific quantity that physicists call the permittivity of free space. The second constant described exactly how strongly magnetic fields form in a vacuum, a quantity known as the permeability of free space. Both of these values had been meticulously measured experimentally by researchers who were working purely on the mechanics of electricity and magnetism. Both were simple numbers that physicists already had written down in their notebooks. Neither of these constants had anything to do with optics, and neither had anything to do with light. Maxwell took these two earthly numbers and plugged them into his newly derived formula for the speed of his theoretical electromagnetic wave. The result that emerged from the mathematics came out to approximately 300 million meters per second. Maxwell recognized that specific number immediately. He recognized it because the true speed of light had already been measured by the astronomers who came before him. Decades prior, in 1676, the Danish astronomer Ole Romer had estimated the speed of light by carefully watching the orbital timing of Io, one of Jupiter's many moons. Romer had noticed a strange celestial anomaly. The eclipses of Io behind Jupiter appeared to run late when the Earth was moving away from Jupiter in its orbit, and they ran early when the Earth was actively approaching Jupiter. Romer Brilliant concluded that this discrepancy occurred because light took physical time to travel the varying distance between Earth and Jupiter, and the travel time literally changed as that massive distance expanded and contracted over the course of Earth's orbit around the Sun. Using only these planetary observations and absolutely no laboratory equipment involved at all, he estimated the speed at roughly 220,000 kilometers per second. It was not perfectly accurate, but it was an astonishingly close measurement for a 17th century mind staring into the dark. Later measurements refined this numerical value considerably. In 1878, Albert Michelson measured the speed of light with unprecedented precision using a highly complex rotating mirror apparatus. He initially set this experiment up at the United States Naval Academy in Annapolis, and he spent years obsessively refining the technique, eventually moving his heavy apparatus to longer baselines in California to achieve better results. Through sheer dedication, Michelson achieved an accuracy within a tiny fraction of a percent of the modern accepted value. He would devote most of his entire career to finding this exact number, returning to it again and again with increasingly sophisticated laboratory equipment. By the time Maxwell was looking at his own mathematical result, physicists already possessed a highly reliable, heavily tested value for how fast light actually moved. It was about 300 million meters per second. It was the exact same number Maxwell got from combining the two terrestrial constants of electricity and magnetism. Think about the profound, staggering weight of this mathematical coincidence. A number measured separately in completely different kinds of experiments by completely different people working on completely different scientific problems turned out to be absolutely identical. In his 1865 paper, Maxwell wrote that the agreement of these results seemed to show that light and the electromagnetic medium were one and the same. This was the grand revelation that shattered the old world. Light was not something separate from electricity and magnetism. Light was an electromagnetic wave. It was a physical ripple in electric and magnetic fields, propagating through the pure vacuum, carrying energy and information at a speed determined entirely by how the vacuum responds to those exact fields. The speed of light was not arbitrary, and it was no longer a cosmic mystery. It fell directly out of those two laboratory-measured constants, the permittivity of free space and the permeability of free space. Two simple numbers measured with capacitors and coils on a tabletop, combined perfectly according to Maxwell's formula, and out came the speed of light. This stands as one of the greatest revelatory moments in the entire history of human science. Three apparently entirely separate phenomena, electricity, magnetism, and light, turned out to be mere aspects of a single, unified theory. And the speed of light fell out of that beautiful unification without anyone having to deliberately put it in. It was a pure prediction that emerged organically from the mathematics, which was then checked against what the astronomers had already measured, and found to be a perfect, undeniable match. But as is always the case in the dark, ever-expanding frontier of physics, answering one profound question simply shifts the burden of the mystery. If the speed of light comes from those two constants, what actually determines the values of those constants? We are forced to confront a deeply unsettling reality about the cosmos we inhabit. The void is not a passive theater where events simply unfold in silence. The vacuum is an active, structural participant in the rendering of reality. The speed of light is not just a description of how fast a photon travels. It is the numerical manifestation of the physical resistance of empty space. The universe governs itself through these invisible, foundational properties. The cosmos weaves together the slow, crawling drift of an electron in a copper wire and the blinding, ancient flash of a distant star using the exact same mathematical thread. The limits of our reality are not imposed from the outside by some grand designer. They are baked intimately into the very fabric of the dark. When we look at the speed of light, we are looking at the bare, exposed machinery of existence itself, quietly waiting to be understood. When we look up at the night sky, our eyes are naturally drawn to the light. We gaze at the burning, ancient stars, the sprawling spiral arms of distant galaxies, and the faint, ghostly glow of distant nebulae. We are biologically conditioned to focus entirely on the matter, on the tangible objects that emit energy and hold shape. Because of this, the human mind is profoundly uncomfortable with the vast, dark stretches in between. We call it empty space. We imagine the vacuum of the cosmos as a perfect, sterile void, an infinite expanse of absolute nothingness that simply serves as a quiet, passive stage for the physical universe to play out its grand dramas. You might intuitively think the vacuum is nothing, the total absence of everything, a perfect void where there are no particles, no fields, and absolutely no energy. This assumption feels safe, and it aligns with our everyday terrestrial experience. But in the deep, strange architecture of reality, you would be entirely wrong. The speed of light is not simply an intrinsic property of a solitary photon racing through a completely empty hallway. In a very direct, mechanical sense, the speed of light is strictly determined by how easily the vacuum of this universe permits electric and magnetic fields to exist and propagate. The void is not passive. It pushes back. It possesses a specific, mathematical texture. Physicists quantify this invisible texture using two highly specific constants. The permittivity of free space tells you how much electric field you get in response to a charge placed in a vacuum. Or, said differently, it measures how easily the vacuum allows an electric field to form and propagate through it. Similarly, the permeability of free space tells you how much magnetic field you get from a current flowing in a vacuum, describing how easily the vacuum allows a magnetic field to form and propagate. Together, these two fundamental numbers determine exactly how freely electromagnetic fields can form and propagate in empty space. They act as a sort of cosmic resistance. A vacuum that resists electric and magnetic fields more strongly, with higher constants, would physically result in a slower speed of light. Conversely, a vacuum that allows fields to form more easily, possessing lower constants, would yield a faster speed of light. Our universe happens to have the particular vacuum properties it has, and so our speed of light is exactly what it is. The light is throttled by the medium it travels through. But this realization immediately forces a profound and unsettling question upon us. If the vacuum has properties, if it possesses a measurable resistance, what exactly is the vacuum? The answer to that question represents one of the most important and deeply counterintuitive discoveries of 20th century physics. As the mathematics of quantum mechanics developed through the 1920s and 1930s, the greatest minds of the era peeled back the layers of classical physics and revealed something deeply unsettling about empty space. The vacuum is not empty. At its absolute bedrock, the vacuum is actually the lowest energy state of every quantum field that exists in nature. To the human mind, the lowest possible state should logically be zero. But in the quantum realm, lowest energy does not mean zero energy. To understand why the universe strictly forbids absolute emptiness, we must confront the strange, unyielding rules of the Heisenberg uncertainty principle. This principle is often stated as a fundamental relationship between a particle's position and its momentum. The more precisely you know where a particle is, the less precisely you can know how fast it is moving, and vice versa. But this mathematical law of uncertainty applies equally to energy and time. The universe demands a baseline level of chaos. The more precisely you know the energy of a quantum system over a given time interval, the less precisely you can know the time at which it possesses that exact energy. Stated another way, the shorter the time interval you attempt to observe, the greater the inherent energy uncertainty in that observation. If the electromagnetic field in the vacuum were exactly zero everywhere, always, its energy would be exactly zero, and perfectly known at every single moment in time. Heisenberg's principle absolutely forbids this from happening. The energy cannot be exactly zero. It must relentlessly fluctuate. Because the field value at every microscopic point in space is perpetually uncertain, the dark void is actually a boiling, seething ocean of mathematical probability. Virtual pairs of particles and antiparticles constantly pop into and out of existence across the entire universe. These phantom particles borrow energy from the vacuum to briefly manifest into reality, and then annihilate one another, returning the borrowed energy before any long-term imbalance can accumulate in the universe's ledger. Physicists call these brief, violent occurrences quantum vacuum fluctuations, or zero-point fluctuations. When you stare into the darkest, emptiest patch of the night sky, you are not looking at nothing. You are looking at an infinite, churning sea of creation and destruction, happening on a timescale so brief it defies human comprehension. It is incredibly tempting to dismiss these virtual particles as mere mathematical accounting tricks. For years, many assumed they were simply theoretical bookkeeping designed to balance the incredibly complex equations of quantum field theory. But the universe does not care about our skepticism. These fluctuations are not theoretical bookkeeping. They are real, and they produce actual, measurable physical effects that have been confirmed in the laboratory to extraordinary precision. The most direct, haunting demonstration of this hidden reality is known as the Casimir effect. Imagine an intricate, highly controlled laboratory experiment. You place two uncharged, perfectly flat, and perfectly parallel metal plates very close together inside a vacuum. You ensure that absolutely nothing electrically connects them. No charge sits on either one of the plates. No magnetic field is actively acting between them, and there is no macroscopic force of any kind pushing or pulling. According to the classical laws of physics, these two plates should remain perfectly still forever. Yet, in defiance of common sense, the plates physically attract each other. They are pushed together by the ghost-like pressure of the void itself. The reason for this impossible movement is that the quantum vacuum fluctuations occurring between the plates are mathematically different from the fluctuations occurring on the outside of the plates. Because the metal plates are conductors, the electric field must be exactly zero at their surfaces. This physical reality imposes a strict boundary condition on the electromagnetic vacuum fluctuations trapped in the microscopic gap. It acts as a cosmic filter. Only fluctuations with specific wavelengths, ones that fit an integer number of times perfectly into twice the gap, are allowed to physically exist inside. Longer wavelengths simply cannot fit. However, outside the plates, in the vast, unrestricted expanse of the open vacuum, no such boundary restriction applies. Out there, all wavelengths are permitted to boil and surge. The result of this geometric restriction is that there are significantly fewer electromagnetic modes and fewer ways for the vacuum to physically fluctuate between the plates than there are on the outside. The vacuum effectively possesses a lower energy density between the plates than it does in the open space beyond them. This energy mismatch is not a theoretical abstraction. It produces a real force, an undeniable net inward pressure physically pushing the heavy metal plates together. The boiling nothingness on the outside is heavier and more violent than the restricted nothingness on the inside. This astonishing phenomenon was predicted theoretically by the Dutch physicist Hendrik Casimir in 1948, as he meticulously worked through the complex mathematics of the zero-point energy of the electromagnetic vacuum. It was measured experimentally first, somewhat roughly, in the 1950s, and then tested with incredibly high precision by the physicist Steve Lamoureux in 1997. The actual force between the plates depends precisely on their separation distance and their surface area. At a microscopic separation of exactly 1 micrometer, the Casimir pressure exerts a force of about 1 Pascal. While this is not a large force by human standards, it is entirely measurable, and it perfectly aligns, fully consistent with the theoretical prediction. Since that time, the Casimir effect has been confirmed again and again in many different configurations, between solid spheres and flat plates, and between different materials with plates constructed of entirely different metals. Every single measurement, in every laboratory, confirms the exact same terrifying and beautiful picture of our reality. The vacuum has real energy. The vacuum has a deep, underlying geometric structure. The vacuum has real physical effects that can move solid metal. The vacuum is simply not nothing. The evidence for this highly active, structured void goes even deeper, reaching into the fundamental building blocks of all matter. One of the most famous demonstrations of the vacuum's physical presence is observed in the anomalous magnetic moment of the electron. In the strange, exacting discipline of quantum mechanics, every single electron possesses an intrinsic property called spin. This spin gives the electron a magnetic moment, which is essentially a way of interacting with external magnetic fields. The basic, foundational prediction from quantum mechanics for the specific size of this magnetic moment yields a highly specific numerical value. But when physicists actually measured the real magnetic moment of the electron very precisely in the laboratory, they discovered a disturbing anomaly. They found it differed from that basic prediction by a tiny, yet undeniable amount. It was not off by much, but it was consistently off. The necessary correction is minute, measuring about 1 part in 1,000. This microscopic discrepancy is caused entirely by the seething void. The full mathematical calculation, utilizing quantum electrodynamics, which is the quantum theory of the electromagnetic force, accounts for this precise correction by including the invisible effects of virtual particles. As the electron drifts through space, it constantly emits and reabsorbs virtual photons. It briefly splits into a virtual electron and a virtual photon before instantly recombining. These relentless fluctuations, the quantum vacuum seething and boiling completely around the electron, physically modify its magnetic moment by a tiny fraction. When those corrections are calculated using the framework of quantum electrodynamics, the resulting theoretical prediction perfectly matches the measured magnetic moment of the electron to 11 decimal places. 11 decimal places. It stands to this day as the most precisely confirmed theoretical prediction in the entire history of science. And it works flawlessly for one singular reason. It works because the vacuum is real. Its invisible fluctuations have real mathematical consequences, and quantum electrodynamics describes those consequences correctly. We are forced to entirely abandon the comforting illusion of an empty universe. The dark spaces between the atoms in your own body and the freezing voids between the distant galaxies share the exact same underlying architecture. The same quantum vacuum whose invisible structure sets the permittivity and permeability of free space is the exact same vacuum whose frantic fluctuations perfectly correct the magnetic moment of the electron to 11 decimal places. The vacuum is physical. Its properties are relentlessly measurable, and one of its most defining, absolute properties is the speed of light. When we ask where light gets its speed from, we are not asking a question about the photon. We are asking a question about the fundamental fabric of existence. The speed of light is the maximum rate at which the universe can process information through this boiling sea of virtual particles. It is the absolute limit of the vacuum's compliance. We exist in a reality where true emptiness is mathematically impossible, where the void itself is a living, breathing participant in the laws of physics. The light we see is merely a ripple on the surface of an infinite, roaring ocean of probability, traveling only as fast as the heavy, structured nothingness of the cosmos will allow. There is a deeply ingrained assumption woven into the very fabric of human psychology, an assumption so fundamentally necessary for our daily survival that we never consciously think to question it. We believe, with absolute conviction, that space and time are rigid, unyielding structures. We experience the world as a fixed, objective stage. A meter is exactly a meter, no matter who is measuring it, and a passing second ticks away at the exact same rhythm for every single being in the cosmos. In this intuitive, classical worldview, motion is always a negotiation between objects. Speeds are entirely relative to one another, constantly adding and subtracting depending on your specific frame of reference. If you are standing on a platform and a train moves past you at 200 kilometers per hour relative to the ground, its speed is an objective calculation of distance over time. If you are riding on that train and you throw a ball forward at 50 kilometers per hour relative to yourself, the physics are effortlessly simple. A person standing still on the platform watches the ball fly by at 150 kilometers per hour. Speeds simply add together in a universe of simple arithmetic. A plane moves at 900 kilometers per hour relative to the air, and somewhat different relative to the ground, depending entirely on the shifting wind. Every speed we encounter in our everyday life is a direct comparison between two distinct things. But towards the end of the 19th century, a terrifying inconsistency began to quietly trouble the minds of the world's greatest physicists. James Clerk Maxwell had successfully unified electricity and magnetism, and his brilliant equations produced a specific, absolute speed for electromagnetic waves propagating in a vacuum. But the equations harbored a dark, unresolved mystery. They provided a speed, but they provided absolutely no reference frame to attach it to. It was not a speed relative to the source of the light, nor was it relative to any physical medium. It was just a staggering speed standing entirely alone, exactly the same regardless of what the source emitting the light was doing. This made absolutely no sense under the comforting umbrella of Newtonian physics. If the simple arithmetic of the moving train applied to the cosmos, then light emitted from a moving source should logically travel at different speeds in different directions when viewed by a stationary observer. A star rushing toward us should cast light that hits our telescopes faster than a star rushing away. To resolve this maddening contradiction, physicists set out to measure the speed of light as the Earth hurtled through the void of space. The most thorough and ambitious test of this era was the Michelson-Morley experiment, conducted in 1887. Albert Michelson, a physicist completely obsessed with precision, alongside Edward Morley, built an exceptionally sensitive device known as an interferometer. The brilliant design of this machine split a single beam of light into two perpendicular paths, sent each path racing to a distant mirror and back, and then carefully recombined the beams. The logic was flawless. If light moved at slightly different speeds in different directions due to the Earth's relentless motion through space, the two recombined beams of light would return slightly out of phase. This microscopic delay would produce a shifted interference pattern, a barcode of light and shadow that would finally prove the classical laws of the universe were safe. The interferometer was incredibly sensitive, more than capable of detecting the expected effect if it actually existed. Michelson and Morley meticulously took their measurements. They rotated the heavy apparatus. They repeated the experiment at different times of the day as the Earth rotated, actively changing the direction of the machine relative to the Earth's orbital motion. They patiently repeated the process at different times of the year as the Earth moved in entirely different directions around the Sun. They hunted for the shift. They found absolutely nothing. There was no shift, and there was no difference in the speed of the returning light. The speed of light was exactly the same in every single direction. The terrifying truth was undeniable. The speed of light remained constant, entirely regardless of the Earth's motion. This result completely baffled physicists. The absolute foundation of mechanics was crumbling, and the problem sat unresolved, haunting the scientific community for almost 2 decades. Some brilliant minds tried to save the classical universe by inventing complex mathematical excuses. The Dutch physicist Hendrik Lorentz and the Irish physicist George Fitzgerald independently developed a mathematical theory suggesting that moving objects physically contract in the direction of their motion by just enough to perfectly cancel out the expected visual effect. While it gave the right numerical answer, it felt incredibly contrived. It was a desperate fix, invented specifically to explain away a deeply inconvenient experimental result. The universe was waiting for someone to simply listen to what it was saying. In 1905, Albert Einstein did exactly that. Einstein did something profoundly different than his predecessors. He completely abandoned the desperate need to protect classical physics. He took the experimental result of Michelson and Morley at face value, and he followed the terrifying logic without flinching. That year, he published what would eventually become the special theory of relativity. Einstein rebuilt the universe upon 2 uncompromising postulates. First, he stated that the laws of physics are exactly the same for all observers in uniform motion relative to each other. An experiment conducted in the sealed hull of a smoothly moving ship must give the exact same results as that very same experiment conducted in a completely stationary laboratory. Second, and far more devastating to our human intuition, he proposed that the speed of light in a vacuum is exactly the same for all such observers, entirely regardless of the motion of the light's source or the motion of the observer. He did not mean it was roughly constant, or constant within a margin of experimental precision. He meant it was exactly constant for every single observer, in every possible state of uniform motion. This sounds like a simple, elegant rule on paper, but the physical implications are so violently counterintuitive that they challenge our very sanity. Imagine you are strapped into a spacecraft, hurtling through the dark void at half the speed of light relative to the Earth. You take out a flashlight and shine a beam of light directly forward into the blackness. According to the classical arithmetic of the moving train, the light from that flashlight should be moving at 1.5 times the speed of light relative to an observer watching you from Earth. But Einstein's universe does not allow this. The light from that flashlight does not move at 1.5 times the speed of light relative to Earth. It moves at exactly the speed of light. It moves at the exact same 299,792,458 meters per second that a completely stationary observer standing on Earth would measure. How is this physically possible? How can a person standing still on a planet and a person hurtling through the void at half the speed of light both measure the exact same beam of light and arrive at the exact same speed? The answer is the price the universe demands to keep the speed of light constant. If the speed of light cannot change, then everything else must break. The profound truth of special relativity is that space and time are not rigid, fixed structures against which motion happens. They are entirely malleable. Space and time themselves physically stretch and compress in highly specific ways that depend entirely on the observer's state of motion. An observer traveling in the fast-moving spacecraft and an observer standing still on Earth fundamentally disagree about how long a given event took to occur. They disagree about how far apart 2 points in space actually are, but they perfectly agree on the speed of light. Their disagreements about the fabric of space and time are precisely mathematically calibrated by the universe to guarantee this absolute agreement on light's speed. Time literally runs at different rates for observers in relative motion. This is not a trick of the mind. It is not a perceptual illusion where moving observers merely think time is running slower. Time actually runs slower. We have proven this visceral reality by taking highly precise atomic clocks, placing them on fast-moving aircraft, and later comparing them to identical clocks left sitting perfectly still on the ground. The airborne clocks lose time precisely by the amount that special relativity predicts. For the speeds of commercial aircraft, the effect is tiny, measured in mere nanoseconds, but it is undeniably real. As our technology has reached further into the sky, this strange manipulation of time has become a daily reality. The fleet of GPS satellites currently orbiting our planet moves at roughly 14,000 kilometers per hour. The time dilation produced by this orbital speed is small, but it is absolutely not negligible. If our engineers did not continuously correct for these relativistic effects, the GPS position estimates beamed down to our phones, and navigation systems would accumulate errors of kilometers every single day. Time dilation is not a philosophical curiosity discussed in academic halls. It is a highly practical, necessary engineering consideration in the most widely used navigation technology on Earth. Physical distances suffer the exact same malleability. Lengths heavily depend on the observer watching them. An object moving at a high speed is physically contracted along its direction of motion when it is carefully measured by a stationary observer. The faster you move through space, the more space itself compresses to accommodate your journey, ensuring that the light racing alongside you never appears to change its pace. What Einstein revealed is that space and time are not two separate, independent backgrounds. They are inextricably linked, twin aspects of one unified, continuous structure that he called spacetime. In this beautifully woven architecture, the speed of light is completely stripped of its mundane definition. It is no longer just the speed at which a photon travels through the dark. It is the fundamental conversion factor between space and time. It is the cosmic exchange rate between two quantities that turn out to simply be different aspects of the exact same underlying thing. This revelation unlocks the deepest, most terrifying power source in the cosmos. Because if the speed of light is the structural conversion factor of reality, its influence does not stop at space and time. It extends into the very substance of matter itself. When you write the most famous equation in human history, E equals meters c squared, the c in that mathematical statement is this exact conversion factor. It dictates that a tiny, microscopic amount of physical mass is mathematically equivalent to an enormous, devastating amount of energy. The reason for this terrifying imbalance is simply because c is a very large number, and c squared, 299,792,458 meters per second multiplied by itself, is an absolutely staggering multiplier. This means that matter and energy are not fundamentally different things. Just like space and time, they are the exact same thing, merely expressed differently by the universe. Mass is simply a highly concentrated, frozen form of energy. Energy possesses an equivalent, underlying mass, and the absolute conversion factor between them, the mechanism that unlocks the frozen fire of matter, is the square of the speed of light. The consequences of this exchange rate govern the life and death of the universe. Every nuclear weapon ever detonated, every nuclear reactor generating power, and every single star burning in the night sky runs entirely on that relationship. Look up at our own sun. Deep within its crushing, violent core, the sun converts about 4 million metric tons of physical mass into pure, radiating energy every single second through the process of nuclear fusion. 4 million metric tons of solid matter are annihilated and converted to pure energy every second. The sun has been engaged in this furious destruction for 4.5 billion years, and it will effortlessly continue to do so for another 5 billion years before its vast reserves of hydrogen finally run low. The only reason a star can sustain this inferno for 10 billion years without burning itself to ash in an instant is entirely because of the immense size of c squared. The energy density locked inside ordinary mass, dictated at the exchange rate set by the speed of light, is large enough to sustain stellar luminosity for timescales that completely dwarf the entire history of life on Earth. We are forced to realize that we live in a reality governed by a single, uncompromising parameter. The speed of light is the architect of our existence. It bends our time, it warps our physical dimensions, and it dictates the violent burning of the stars that give us life. We walk upon a stage that feels solid and dependable, but that solidity is an illusion, maintained only by the relentless stretching and compressing of space-time, all to protect the absolute sovereignty of a single number. When we look up at the vast, silent dark of the night sky, we naturally assume that the defining variable of the universe is light itself. We call it the speed of light. We build our telescopes to capture it, we calculate the age of distant galaxies by the time it takes to reach our eyes, and we marvel at the staggering constant of nearly 300,000 kilometers per second. But there is a deeply unsettling secret hiding at the very foundation of theoretical physics. Light is merely a passenger. The parameter we call c is not fundamentally a property of electromagnetic waves, nor is it a quirk of photons. If you were to completely erase every photon in existence, if you were to drain the cosmos of every star, every spark, and every beam of light, the number c would remain completely unchanged. It is baked directly into the space-time metric, the foundational mathematical object that defines what distance, duration, and geometry actually mean throughout reality. Change c, and you do not simply alter how fast a light wave moves. You alter the relationship between cause and effect. You rewrite the rules of physical influence. You fundamentally break the logical coherence of time itself. This is why modern physics views c not as a speed limit for light, but as the absolute speed limit for causality. Nothing in existence can travel faster than c. This is not a technical limitation that humanity might one day overcome with superior engineering or exotic technology. It is a strict mathematical consequence of the logical structure of space-time. Matter cannot exceed c, because as physical mass accelerates toward this limit, the energy required to push it further approaches infinity. Energy cannot travel faster than c, nor can gravity, nor can physical information, nor can any physical influence of any kind. C is the absolute maximum rate at which an event occurring at one point in space can possibly cause an event to occur at another point in space. It is the velocity of cause and effect. To understand why this speed limit is a logical requirement for a coherent universe, we must confront the horrifying paradoxes that emerge the moment you attempt to break it. In the framework of special relativity, space and time are not rigid, independent backgrounds. They are interwoven, malleable dimensions that stretch and compress depending on an observer's state of motion. Because of this, two observers moving relative to one another can fundamentally disagree about the sequence of events separated by vast distances in space. Imagine two distant events occurring far apart in the cosmos. If those two events are positioned such that light or any signal moving at c or slower cannot travel between them in the time elapsed, their chronological order is not absolute. One observer, sitting stationary, might measure event A occurring before event B. A second observer, traveling through space at a high rate of speed in a different direction, will legitimately measure event B occurring before event A. Both observers are entirely correct within their own frames of reference. This sounds like a violation of common sense, but under normal circumstances, it causes zero physical contradictions. Why? Because the two events are causally disconnected. Nothing moving at or below C can get from event A to event B, or from event B to event A. No physical chain of cause and effect can ever link them. The chronological order of those two events has no physical significance, because neither event could have possibly caused the other. Causality is flawlessly preserved precisely because nothing can travel fast enough to bridge the gap. Now, imagine what happens if you break the rules. Imagine a hypothetical device that could transmit information faster than c. If you possess a superluminal communicator, you can suddenly bridge that causally disconnected gap. You can send a signal from event A to event B. In your own frame of reference, you send the signal forward in time and it arrives at its destination. But to that second observer moving in the right direction at the right speed, your signal does not just travel faster than light, it travels backward through time. Using their frame of reference, that second observer could bounce your signal back to you using a matching superluminal device. When you receive the return message on Earth, it will arrive before you ever sent the original transmission. You could receive an answer to a question you have not yet asked. You could be warned about a decision you have not yet made. You could alter your past, prevent your own actions, and destroy the logical thread that allowed the signal to be generated in the first place. This is not merely a confusing sci-fi trope. It is a catastrophic breakdown of physical reality. If information can travel faster than c, cause and effect collapse into a meaningless, chaotic loop. The universe loses its logical consistency. The past, present, and future cease to be an ordered progression, dissolving into a self-contradictory nightmare where effects precede their causes. The absolute speed limit, c, is the cosmic firewall that prevents the universe from descending into complete logical self-annihilation. It is the universe's way of ensuring that history can actually happen. Physicists visualize this rigid, geometric structure of causality through a deeply elegant concept known as the light cone. Imagine a simple diagram where space extends horizontally and time flows relentlessly upward. You sit at the exact center of this diagram, your localized point in space and time, your immediate here and now. If you were to flash a pulse of light in all directions simultaneously, that light would expand outward as a growing sphere in 3 spatial dimensions. On our spacetime diagram, the path traced out by this expanding sphere forms a perfect, expanding cone extending into the future. The outer walls of this cone represent the paths of photons traveling through the vacuum at sea. This is your future light cone. The future light cone is not just a visual representation of light rays. It is the strict geometric boundary of your entire future destiny. Every single event in the universe that you can ever potentially affect, every person you can ever communicate with, every planet you can ever visit, and every physical action you can ever perform sits strictly inside or directly on the surface of your future light cone. If an event sits outside your future light cone, it is completely unreachable. No matter how much energy you expend, no matter how advanced your technology becomes, you can never send a signal, a particle, or a physical influence to that event. It is permanently insulated from your existence. Conversely, extending downward from your current moment into the past is your past light cone. This cone encompasses every single event in the history of the universe that could have potentially influenced your current reality. Every photon that strikes your retina, every gravitational wave that gently stretches your body, and every cosmic ray that passes through your environment originated from an event sitting inside or on the surface of your past light cone. Events sitting outside your past light cone could not have caused anything happening to you right now. They are physically irrelevant to your present moment. The light cone divides the entire, sprawling architecture of 4-dimensional space-time into 3 distinct, unyielding regions: the causal past, which created you, the causal future, which you can create, and the vast, causally disconnected elsewhere. This third region, the causally disconnected elsewhere, is perhaps the most profound and humbling aspect of modern cosmology. It represents the enormous volume of reality that has no physical connection to your present moment whatsoever. Events are occurring right now across the deep universe that you cannot observe, cannot influence, and cannot be affected by. They do not sit in your past, and they do not sit in your future. They exist in an absolute, inaccessible elsewhere, entirely separated from your reality by the unyielding boundary of C, the surface of the light cone. The precise geometric envelope defined by C is the ultimate horizon of information. It is the boundary between what can and cannot be linked by cause and effect. Change the numerical value of C, and you do not simply speed up or slow down a beam of light. You tilt the light cones throughout the entire universe. You widen or narrow the scope of human agency. You rewrite the boundaries of what any conscious observer can ever know or affect. When we process this geometric reality, our understanding of space and time undergoes a radical philosophical shift. We are accustomed to thinking of time as a relentless, flowing river, and space as an empty, static container. But the existence of the light cone proves that space-time is an active, structured network of information. Distance is not just a measurement of meters, it is a measurement of delay. Duration is not just a ticking clock, it is the interval required for physical information to process across the network. The finite nature of C guarantees that the universe is fundamentally local in its operations of cause and effect. It prevents every event in the cosmos from happening all at once. If C were infinite, every gravitational pull, every electromagnetic push, and every physical interaction across the entire expanse of space would occur instantaneously. There would be no delay, no sequence, and no history. The universe would be forced to process every calculation simultaneously, collapsing the entire story of reality into a single, blinding, instantaneous flash. The finite speed of causality is what grants the universe its narrative structure. It is what gives space its volume and time its rhythm. This reveals a profound truth about the nature of information and physical reality. Information is not an abstract concept invented by human minds to write books or build computers. Information is the foundational currency of the universe. Every physical interaction, an electron absorbing a photon, a planet pulling on a moon, a chemical bond forming in a strand of DNA, is an exchange of information. And c is the absolute processing speed of the cosmic rendering engine. It is the clock rate of reality itself. When we stand outside in the quiet dark and look up at the stars, we are staring directly at the physical geometry of this computational limit. We see stars as they existed years, centuries, or millennia ago, not because our technology is limited, but because the universe physically cannot process the information of their present state to our location any faster. The delay is built into the metric. We are trapped inside our own localized light cones, forever insulated from the absolute present of the distant cosmos, navigating a reality where history is constantly being rendered at the exact, unyielding rate of c. We spend our brief lives moving through a world shaped entirely by cause and effect. We take for granted that our actions today will yield consequences tomorrow, that our memories belong to a fixed past, and that the future remains an open canvas of possibility. But that logical coherence, the very sanity of human existence, is quietly guarded by an invisible mathematical boundary. The speed of light is not a number belonging to a photon. It is the ultimate speed limit of reality, the unyielding law that ensures the universe remains a logical, ordered story, holding the chaotic dark at bay, 1 second and 300,000 kilometers at a time. We walk the earth feeling the heavy, undeniable pull of gravity. We experience the world through the physical sensation of weight, resistance, and solidity. We are bound to the ground, anchored to the slow, steady march of time, and we naturally assume that mass is simply an inherent, inescapable property of matter. We believe a stone is heavy merely because it is a stone. But in the strange, microscopic depths of theoretical physics, mass is not a solid object. Mass is an event. It is a continuous, relentless interaction with the invisible fabric of the cosmos. To truly understand why light travels at the absolute speed limit of the universe, we must first understand why absolutely everything else fails to keep up. We must look past the illusion of solid matter and confront the true origin of mass. In the mid-20th century, the standard model of particle physics faced a terrifying mathematical crisis. The equations that successfully unified the electromagnetic force with the weak nuclear force into a single, elegant framework demanded a strict, uncompromising perfection. The mathematical rules governing this unification, known as gauge symmetry, strictly required that the subatomic particles carrying these fundamental forces must possess absolutely no mass. For the photon, the carrier of the electromagnetic force, this was perfectly fine. But the carriers of the weak nuclear force, the W and Z bosons, were undeniably, aggressively massive. They are roughly 100 times heavier than a single proton. The foundational mathematics of the universe stated they should weigh nothing, but experimental reality proved they were incredibly heavy. The theory was on the verge of total collapse. To resolve this devastating contradiction, physicists proposed a radical, almost heretical idea. They suggested that the vacuum of space is not just filled with boiling quantum fluctuations, but is completely saturated by an invisible, static energy field that permeates every single millimeter of the universe. This is the Higgs field. It sits at a non-zero energy level everywhere, acting like a cosmic molasses filling the great dark. When particles travel through the universe, they do not fly through an empty room. They are forced to wade through this dense, invisible field. The W and Z bosons interact fiercely with the Higgs field. They drag against it, they tangle with its energy, and this intense, constant interaction requires effort. In the quantum realm, this continuous energy exchange is exactly what manifests as physical mass. The W and Z bosons are not inherently heavy, they are simply bogged down by the vacuum itself. They are staggering through the void. But amidst this cosmic friction, the photon is an entirely unique entity. The photon is completely protected by the absolute laws of gauge symmetry. This mathematical armor strictly forbids the photon from interacting with the Higgs field. As a photon races across the universe, it glides through the dense, invisible energy of the vacuum without leaving a single ripple. It feels absolutely no drag. It engages in zero energy exchange with the Higgs field. Because of this perfect, pristine isolation, the photon remains completely and utterly massless. It is this absolute absence of mass that dictates its terrifying speed. In the architecture of spacetime, traveling at the ultimate speed limit of causality is not a special privilege granted only to light. It is the default state of the entire universe. If you have no mass, you possess no physical anchor to the stationary fabric of space. You have no inertia. Therefore, the universe has no mechanism to hold you back. The moment a massless particle is born, it is instantaneously, violently propelled to the absolute maximum speed the geometry of reality will allow. It is forced to travel at the speed of light. Light does not accelerate. It does not gradually build up its pace. From the exact microsecond of its creation, the photon is already moving at nearly 300,000 kilometers per second, simply because it is physically impossible for a truly massless entity to move any slower. This pristine masslessness carries profound, universe-altering consequences. In quantum mechanics, the fundamental forces of nature are transmitted through the continuous exchange of these carrier particles. Because the W and Z bosons are incredibly heavy, continually bogged down by the Higgs field, they require an enormous amount of borrowed energy to manifest in the real world. The strict rules of quantum uncertainty dictate that a massive virtual particle can only borrow that vast amount of energy for a fleeting, microscopic fraction of a second before it must pay it back and vanish into the vacuum. Consequently, the weak nuclear force has a pathetic, incredibly short range. It can barely reach across the diameter of a single atomic nucleus. It is a suffocated, highly localized force, restricted entirely to the subatomic realm. Now, consider the electromagnetic force carried by the massless photon. Because the photon costs zero resting energy to create, it can be exchanged over vast, unimaginable distances. It never runs out of time. This absolute masslessness dictates that the electromagnetic force has an infinite range. If you place an electron on Earth and a proton on the absolute furthest edge of the observable universe, billions of light years away, they will technically still exert an invisible electromagnetic pull on one another. The force diminishes over the vast distance, fading into the dark, but it never strictly reaches zero. This infinite, sprawling reach is the only reason you are alive to hear these words. If the photon interacted with the Higgs field even a tiny fraction of a percent, if it possessed even the smallest imaginable sliver of mass, the electromagnetic force would instantly become short-ranged, much like the weak nuclear force. Electrons would no longer be bound to the nuclei of atoms over the relatively vast, open distances of atomic orbitals. The intricate, delicate dance of chemistry would immediately fail. Molecules could not form. The long strands of DNA could not hold their complex, folding structures. The biological machinery of your brain, which runs entirely on the long-range electromagnetic exchange of charged ions, would completely halt. Our very existence as complex, thinking entities relies entirely on the photon's pristine, mathematical refusal to interact with the invisible Higgs field. We are the direct, biological beneficiaries of its absolute masslessness. But what happens if a particle is almost, but not quite, massless? For decades, physicists believed there was another invisible ghost haunting the cosmic machine: the neutrino. These elusive, electrically neutral particles are produced in the furious nuclear furnaces of burning stars and the violent collisions of high-energy cosmic rays. Trillions of them pass seamlessly through your body every single second, completely unhindered by the solid matter of the Earth. Because they interact so weakly with the world, and because they travel so incredibly fast, the standard model of particle physics initially assumed that neutrinos, exactly like photons, were perfectly massless. The universe, however, harbors no assumptions. In February of 1987, humanity was gifted a profound and violent cosmic laboratory. A massive, aging star in the large Magellanic Cloud, a small companion galaxy roughly 160,000 light-years away from Earth, finally exhausted its nuclear fuel. Its core catastrophically collapsed under its own crushing gravity, triggering one of the most spectacular events in nature, a supernova. The resulting explosion, designated Supernova 1987A, burned with the blinding light of 100 million suns. When the star's core initially collapsed, the catastrophic implosion generated an unimaginable, dense flood of neutrinos. Because neutrinos interact so weakly with ordinary matter, they instantly slipped through the incredibly dense, collapsing outer layers of the dying star and fled directly into the vacuum of space. The optical photons, however, were trapped. They spent hours violently bouncing around inside the dense, expanding shockwave of stellar debris before they finally broke through the surface and surged out into the dark. Thus, the neutrinos got a 3-hour head start on a journey that would take 160,000 years to complete. On Earth, deep underground observatories carefully registered the arrival of a handful of these ghostly neutrinos, mere hours before the visual optical light of the supernova bloomed brightly in our astronomical telescopes. But the most profound discovery was not the simple fact that the neutrinos arrived early. The profound discovery was exactly how they arrived. The neutrinos did not strike the Earth in a single, perfectly simultaneous wave. Instead, they arrived slightly spread out in time, trickling into the subterranean detectors over a distinct span of several seconds. This microscopic delay held the secrets of the cosmos. If neutrinos were perfectly massless, they would be strictly mandated by the laws of physics to travel at exactly the speed of light. In a pure vacuum, every single massless particle travels at the exact same, absolute speed, regardless of how much energy it carries. If they were truly massless, they would have crossed the 160,000 light-year gulf and arrived at Earth grouped exactly as tightly as they were when they left the exploding core. The fact that they arrived slightly spread out in time meant something entirely different. It meant that the neutrinos possessing slightly lower kinetic energy were physically traveling slightly slower than the neutrinos possessing higher kinetic energy. They were racing each other across the cosmic void, and some were falling behind. This physical dispersion over vast interstellar distances is absolute, undeniable proof of mass. It proved that neutrinos interact, ever so slightly, with the Higgs field. They possess a physical mass that is millions of times smaller than that of a single electron, a mass so incredibly faint it is almost beyond human comprehension. But in the unforgiving geometry of space-time, the difference between almost zero and exactly zero is everything. Because they possess a tiny sliver of mass, they cannot travel at exactly the speed of light. They travel incredibly close to it, skimming the absolute edge of causality, but they can never quite touch the boundary. The universe is governed by this brutal, mathematical dichotomy. You either possess mass or you do not. There is no middle ground, and there is no negotiation. If you have mass, you are subject to the slow, agonizing drag of the vacuum. You have a past, you experience a present, and you move relentlessly toward a future. You age, you decay. You are firmly anchored to the physical world, forced to crawl through the void at a fraction of the ultimate speed. We, along with the planets, the stars, and the towering galaxies, are all creatures of mass, bound heavily to the slow ticking of the cosmic clock. But if you are a photon, perfectly shielded by the elegant laws of gauge symmetry, you carry no mass at all. You do not feel the dense drag of the vacuum. You are completely untethered from the constraints of time. For the massless photon, traversing the infinite dark is not a journey. Because you travel at exactly the speed of causality, relativity dictates that you do not experience the passage of time. From your perspective, the exact moment you are born in the violent, raging heart of a dying star, and the exact moment you strike the retina of a human eye looking up at the night sky are the exact same moment. Light does not age. It only exists, rushing perfectly through the dark, showing us a universe that we can see but can never truly catch. For the entirety of human history, we have been prisoners of an intuitive illusion. From the moment we take our first unsteady steps, we experience gravity as an invisible, relentless tether pulling us downward. We feel it as a mechanical force, an inescapable magnetism that anchors us to the spinning surface of our world. For centuries, classical physics validated this terrestrial instinct, treating gravity as a mysterious, instantaneous rope connecting every piece of matter in the cosmos across a vast, empty stage. But the universe is not a stage, and gravity is not a rope. The profound paradigm shift that permanently dismantled our classical understanding of the cosmos began with Albert Einstein. Einstein's general theory of relativity, which he completed in 1915, describes gravity not as a force, but as the physical curvature of space-time produced by mass and energy. He realized that the fabric of reality itself is entirely malleable. A massive object, like a star or a planet, physically curves the space-time immediately around it. The void is not empty, it has geometry. When other objects are moving freely through that curved space-time, they are simply forced to follow curved paths. What our minds interpret and what we call the gravitational pull of a massive object is really just the curvature of space-time directing freely moving objects toward it. The Earth is not pulling the Moon through a mysterious, invisible attraction. The Earth has warped the spatial fabric around it, and the Moon is merely rolling along the contours of that cosmic depression. This geometric revelation immediately birthed one of the most profound and challenging questions in modern physics. If gravity is not a magnetic tether pulling on heavy objects, but rather the actual warping of the spatial road itself, what happens to something that has no mass? What happens to light? Gravity affects light, but light possesses absolutely no mass. Therefore, gravity is not pulling on its mass. Instead, it is curving the space-time that light must move through. When a photon travels across the universe, it always travels in a perfectly straight line through its own local space. But if that local space has been warped by a massive object, the light follows the curvature of space-time. One of the first, most critical tests of general relativity was the bending of light by gravity. The logic was inescapable. If space-time is curved by mass, then light traveling through curved space-time should follow curved paths. Specifically, the path of a light ray originating from a distant star and passing incredibly close to our own sun should be physically bent toward the sun before it reaches our eyes. The scientific stakes were monumentally high. Newton's classical theory of gravity actually predicts a bending of light too, provided you treat light as a stream of particles with an effective mass given by their energy. But Einstein's radical new geometry demanded something different. General relativity predicts exactly twice the bending that Newton's theory predicts. The cosmos offered two conflicting mathematical prophecies, and humanity needed a cosmic laboratory to determine the truth. The brilliant, fleeting opportunity to test it came in May 1919 during a total solar eclipse. Under normal circumstances, the blinding, overwhelming glare of our star completely washes out the faint light of distant celestial bodies. However, during totality, the moon perfectly blocks the sun, and the faint, distant stars sitting directly near the sun's edge suddenly become visible in the darkened daytime sky. The scientific community mobilized to capture this fleeting shadow. The British astronomer Arthur Eddington boldly led an expedition to the remote island of Principe, located off the west coast of Africa, to carefully observe the eclipse. Simultaneously, another dedicated team went to Sobral in Brazil to take their own measurements. In the sudden, eerie twilight of totality, they painstakingly photographed the stars near the sun. They then took those fragile photographic plates and rigorously compared the positions of those specific stars to photographs of the exact same star field taken months earlier when the sun was nowhere nearby. The astronomical results were undeniably staggering. The stars appeared shifted by approximately 1.7 arcseconds. This microscopic displacement perfectly matched the general relativistic prediction, not the Newtonian prediction. Einstein was right. Light physically bends in a gravitational field by exactly twice what Newton had originally predicted. This was not merely a victory for a new mathematical equation. It was a total redefinition of reality. The speed of light is again woven directly into the fundamental geometry of curved spacetime. This physical value appears prominently in the geodesic equations of general relativity, dictating the precise way that gravity acts on light in the Schwarzschild metric, which mathematically describes the geometry of spacetime around a massive body like a planet or a burning star. Light and gravity were no longer separate actors on a stage. They were intimately bound by the exact same geometric rules. But if a star can gently curve spacetime enough to slightly bend a beam of starlight, what happens when that curvature is pushed to the absolute, terrifying extreme? When a truly massive star finally exhausts its nuclear fuel, it can no longer support its own crushing weight. It violently collapses inward, tearing a bottomless pit in the fabric of reality. Black holes are the most extreme manifestation of this phenomenon. A black hole is a region of spacetime where the curvature is so violent and so extreme that absolutely nothing, not matter, not radiation, and not even light, can escape once it passes inside the event horizon. The event horizon is a concept that challenges the limits of human imagination. The event horizon is not a physical surface. You cannot land on it, you cannot touch it, and it has no material substance. It is strictly a boundary in space-time. It is the invisible, mathematical point of no return, where the fabric of the universe is plunging inward faster than the absolute cosmic speed limit. This terrifying boundary is entirely defined by one single parameter. At the exact edge of the event horizon, the escape velocity equals the speed of light. Below the event horizon, falling deeper into the gravitational abyss, the required escape velocity exceeds the speed of light. Since nothing in the entire cosmos can travel faster than the speed of light, Nothing that passes inside the event horizon can ever escape. The speed of light defines the event horizon. It is the architect of the cosmic trap. Everything about the anatomy of a black hole is intimately, inextricably tied to this specific cosmic speed limit. The Schwarzschild radius is the critical radius at which a collapsing object of a given mass irrevocably becomes a black hole, and this radius is calculated by multiplying the gravitational constant times the mass and then dividing it by the speed of light squared. If the fundamental speed of light were completely different in our universe, black holes would be entirely different entities. Their event horizons would be located at entirely different distances from their center. A smaller speed of light would mean a significantly larger Schwarzschild radius. Consequently, objects of a given mass would become black holes much more easily, triggering catastrophic collapses across the cosmos under far less extreme conditions. The foundational structure of black holes, and the relationship between their crushing mass and the size of the dark region from which nothing can ever return, is definitively set by the speed of light. For nearly a century, black holes remained silent, terrifying phantoms, holding their secrets behind an impenetrable wall of warped geometry. We knew they existed by watching how they consumed matter and threw nearby stars into violent orbits, but we had never directly felt the immense, raw power of their collisions. We had never felt space-time itself actively shuddering under their weight. That profound silence was finally broken. The detection of gravitational waves by the Laser Interferometer Gravitational Wave Observatory, known as LIGO, in September 2015 was a landmark event in human history. For the very first time, physicists directly detected physical ripples in space-time itself. The cataclysmic waves that washed over our planet on that quiet September day were produced by two colossal black holes engaged in a violent, spiraling death dance, ultimately merging about 1.3 billion light-years away. The merger itself happened in the deep, ancient past, about 1.3 billion years ago. In the final, chaotic fractions of a second before they coalesced, they converted an unimaginable amount of their combined mass directly into pure, radiating gravitational energy. The resulting gravitational waves spread outward from the violent merger exactly at the speed of light. They did not ripple outward at the speed of sound. They did not travel at some mysterious, independent gravity wave speed. They traveled precisely, undeniably at the speed of light. Gravitational waves travel at the speed of light because they are fundamental disturbances in space-time, and the absolute maximum speed at which any space-time disturbances can ever propagate is the speed of light. Imagine the haunting, silent journey of that invisible ripple. It expanded outward through the dark, rushing across the freezing voids between distant galaxies, maintaining its perfect, absolute speed for over 1 billion years. It traveled while the continents on our small world slowly drifted apart and smashed back together. It traveled while countless generations of terrestrial life evolved, flourished, and went extinct. It traveled flawlessly through the expanding dark, carrying the dying echo of two monstrous black holes, completely bound by the geometric speed limit of the universe. When the invisible waves finally reached Earth 1.3 billion years later, they swept through our solar system, passing completely unhindered through our planet, through our cities, and through our very bodies. As they passed, they physically stretched and compressed space-time at the location of the LIGO detectors by an amount equivalent to about 1,000th the diameter of a single proton. The LIGO detectors are massive, incredibly complex interferometers designed with perpendicular vacuum arms stretching 4 kilometers long, and they miraculously detected this minuscule, subatomic distortion. This monumental achievement was not an isolated anomaly. Subsequent astronomical detections have flawlessly confirmed the same staggering picture. Gravitational waves radiating from other merging black holes, and the violent shock waves echoing from merging neutron stars, all travel exclusively at the speed of light. This reveals a beautiful, almost terrifying symmetry hidden deep within the foundational code of reality. A beam of ancient starlight crossing the galaxy, and a violent ripple in the geometry of gravity itself, are both bound by the exact same unyielding speed limit. All disturbances in spacetime, whether they are electromagnetic or gravitational, are mandated to propagate at the exact same speed. It is the speed built inherently into the geometry itself. We are forced to recognize that the speed of light is so much more than a simple measurement of velocity. It is the absolute elasticity of the universe. It is the supreme governor of cause and effect, dictating precisely how fast the cosmos can react to its own internal changes. It is the mathematical tether that binds the quiet, invisible glow of a quantum fluctuation to the catastrophic, universe-shaking collision of massive black holes. The universe is a singular, connected, vibrating web of geometry, and the speed of light is the beautiful, relentless rhythm of its breathing. When we cast our minds out into the deep cosmos, we naturally imagine the speed of light as a boundary that only matters in the terrifying, freezing voids between the distant stars. We think of it as an astronomical speed limit, a rule that strictly governs how fast a solitary photon can cross the vast, empty gulf separating our planet from the Andromeda galaxy. Because of this, it is incredibly easy to view the speed of light as something entirely external to the human experience. It feels like an abstract, cold parameter of astrophysics, deeply disconnected from the warm, chaotic reality of our everyday biological lives. But this is a profound illusion. The speed of light does not just exist out there in the dark. It is quietly, fundamentally woven into the very blood in your veins, the structure of your DNA, and the electrical firing of the neurons in your brain. To understand how a cosmic speed limit dictates the fragile architecture of biology, we must examine one of the most mysterious and haunting numbers in all of theoretical physics. It is known as the fine structure constant, and it carries the mathematical symbol alpha. Unlike the speed of light, which is measured in meters per second, or the mass of an electron, which is measured in kilograms, the fine structure constant is something entirely different. It has no units. It is not a measurement of distance, nor time, nor mass. It is a dimensionless number, a pure ratio. When physicists measure this constant in the laboratory, its value is approximately 1/137. More precisely, it is about 0.00072973. This specific, dimensionless fraction is built from three other fundamental constants of nature, elegantly combined in a highly specific way. It is constructed from the elementary charge of the electron, Planck's constant, and the speed of light. Planck's constant is the foundational metric that sets the scale of all quantum effects throughout the universe. By binding the electron charge, the quantum scale, and the speed of light together, the fine structure constant emerges as a pure, naked ratio that perfectly describes the strength of electromagnetism. It tells you exactly how strongly electrically charged particles interact with photons. For decades, the existence of this pure number has haunted the greatest minds in physics. The legendary theoretical physicist Wolfgang Pauli spent years of his life obsessively trying to derive its exact value from some deeper, underlying mathematical principle. He never succeeded. It is said that Pauli wanted nothing more than to understand exactly why this pure number was approximately 1/137 before he left this world. The question haunted him so deeply because that specific number cannot be derived from any deeper theory we currently have in modern physics. It is simply measured. It sits at the foundation of reality like a piece of alien code, a password to the universe that works flawlessly but comes with absolutely no explanation of its origin. But while its origin remains shrouded in mystery, its ultimate power over the physical world is undeniable. The fine structure constant is the invisible architect of the atomic realm. It dictates exactly how tightly electrons are bound in atomic orbitals around the dense nuclei of atoms. Because of this, the physical sizes of those orbitals depend entirely on it. A larger fine structure constant would mathematically mean that electrons are bound far more tightly, resulting in much smaller atomic orbits. A smaller fine structure constant would mean they are bound much more loosely, resulting in larger atomic orbits. This delicate spacing determines the very nature of matter. The fine structure constant directly controls the specific energies at which atoms can absorb and emit light, the characteristic colors of light emitted by different elements. The unique spectral fingerprints that astronomers use to carefully identify what distant stars are made of are all determined by the fine structure constant. When we transition from the cold equations of atomic physics to the rich, complex world of biology, the influence of this pure ratio becomes staggeringly intimate. Because the fine structure constant governs how electrons behave and interact, every single chemical bond in existence depends on it. Every molecule in the universe owes its physical stability and its chemical properties entirely to the fine structure constant. Consider the intricate, spiraling architecture of your own biology. The exact structure of DNA depends on it. The immensely complex, three-dimensional folding of proteins depends on it. The highly specific function of enzymes, the precise rate of metabolic reactions keeping your cells alive, and the rapid electrical firing of neurons in your brain all depend on it. The spark of human consciousness, driven by the cascade of charged ions across a synaptic gap, is fundamentally governed by a pure mathematical ratio that contains the speed of light. The universe is exquisitely sensitive to the exact value of the speed of light, not because light itself is particularly special, but because the speed of light is completely woven into atomic physics through the fine structure constant, which rigorously governs the chemistry that every living thing strictly depends on. If you were to change the speed of light while holding the electron charge and Planck's constant permanently fixed, the fine structure constant would inevitably change. Change that constant enough, and the foundational rules of atomic physics completely change. Change atomic physics, and the laws of chemistry violently change. Change chemistry, and biology immediately becomes impossible. But the delicate knife edge of our existence goes even deeper than the chemical bonds holding our fragile bodies together. To truly appreciate the existential weight of the fine structure constant, we must look away from the microscopic interior of the human cell and gaze deep into the violent, raging heart of a burning star. The fine structure constant connects to the heavy machinery of nuclear physics through an entirely different, yet equally critical pathway. The colossal nuclear reactions that actively power the stars in our night sky strictly require particles to successfully tunnel through massive electrostatic barriers. In the crushing, turbulent core of our own sun, the star is relentlessly trying to fuse hydrogen nuclei, which are protons, into heavier helium nuclei. For this spectacular fusion to happen, two positively charged protons must somehow approach close enough to one another for the strong nuclear force to finally take over. The strong nuclear force is the immensely powerful cosmic glue that binds protons and neutrons together in atomic nuclei. However, it acts only over very short, microscopic distances. Meanwhile, The electromagnetic force aggressively repels the two positively charged protons at larger distances. This creates a brutal subatomic battle. The protons are desperately trying to smash together, but the electromagnetic force throws up a towering, invisible wall of repulsion, pushing them violently apart before the strong nuclear force can ever reach out and grab them. In the core of a star, temperatures soar to an unimaginable tens of millions of degrees. The protons are moving incredibly fast, violently slamming into one another in the dark. But despite this catastrophic heat, they are still not moving fast enough, according to the laws of classical physics, to overcome the immense electromagnetic barrier. Classically speaking, stellar fusion is completely impossible. The sun should not be able to burn. To survive this classical impossibility, the universe relies on a strange, ghostly loophole. Quantum tunneling is required. Through the bizarre, probabilistic laws of quantum mechanics, a proton can occasionally just tunnel straight through the solid electromagnetic barrier that it classically could not surmount. It magically bypasses the wall, allowing the strong nuclear force to take hold, fusing the particles and releasing the blinding energy that eventually warms our planet. But this magical tunneling is not guaranteed. It is a game of subatomic roulette. The probability of this tunneling actually occurring depends entirely on the ratio of the electromagnetic repulsion energy to the proton's kinetic energy. And that critical electromagnetic repulsion is governed by the fine structure constant, which ultimately depends on the speed of light. The exact height of the electromagnetic barrier between the protons is strictly set by this constant. This creates a terrifying chain of cosmic dependencies. If the speed of light were different, the fine structure constant would inherently be different. If the constant changed, the height of the electromagnetic barrier would be completely different. This would dictate that the quantum tunneling probability would be different. And if the tunneling probability changed, the entire rate of nuclear fusion inside every star in the universe would be different. Stars would burn at entirely different rates. Imagine a universe where this pure ratio is shifted just slightly out of balance. If the fine structure constant were much larger, the electromagnetic barrier between protons would be significantly higher. The quantum tunneling probability would drastically drop. As a result, stars would fuse hydrogen much more slowly. They would be incredibly cooler and much dimmer, forced to burn as faint, dying embers, though they would be extremely long-lived. They would fail to provide the radiant energy required to thaw a frozen world and sustain a biosphere. Conversely, imagine a universe where the fine structure constant is shifted the other way. If the constant were much smaller, the electromagnetic barrier would be much lower. Fusion would happen far too easily. Stars would burn through their massive hydrogen reserves far too fast, detonating their fuel in brief, violent flashes of cosmic time. In this universe, there would be no stable stars peacefully burning for billions of years. There would simply be no time for planetary systems to slowly form, for oceans to cool, and for the agonizingly slow process of biological life to evolve and develop. We exist perfectly balanced on a mathematical razor's edge. The specific value of the speed of light directly contributes to the specific value of the fine structure constant. This, in turn, contributes to the specific rate of nuclear fusion inside stars. And that specific rate of fusion directly contributes to the age and the incredible stability of the universe required for biological life to finally emerge from the dust. It is all intimately, beautifully connected. When we comprehend the full, staggering weight of this reality, the universe stops looking like a collection of random, disconnected phenomena. We are forced to abandon the idea that humanity is just a biological accident wandering through a cold, indifferent machine. The speed of light is not an arbitrary limit designed to keep the distant galaxies forever out of our reach. It is the fundamental tuning dial of our existence. The exact numerical value that dictates how fast a photon races across the vacuum of space is the exact same numerical value that ensures a star burns long enough to foster a living world. It is the exact same numerical value that allows the carbon, oxygen, and nitrogen in your body to perfectly bind together in the intricate dance of organic chemistry. It is the exact same numerical value that allows the electrical impulses in your brain to process the profound wonder of your own existence. We are not merely temporary observers looking out into the cosmos. We are the highly improbable, beautifully orchestrated product of its deepest mathematical laws. We are made of the constants. The speed of light is the scaffolding of our reality, holding the chaotic forces of the subatomic realm in a perfect, fragile harmony, allowing the universe the precious billions of years of quiet stability it needed to finally open its eyes and to begin asking exactly where the light actually comes from. When you step outside into the dark and tilt your head up toward the sprawling canopy of the night sky, you are engaging in a profound physical illusion. You are not seeing the universe as it currently exists. You are seeing it exactly as it was. Light travels incredibly fast, but the universe is almost unimaginably large. Because of this vastness, every photon that strikes your retina is a relic of the past, a delayed message from a cosmos that has already moved on. Light from our own moon takes about 1.3 seconds to bridge the gap to Earth. When you look at the lunar surface, you are seeing it as it was a moment ago. Light from the sun takes over 8 minutes to make the journey. If the sun were to suddenly extinguish, we would continue to orbit a ghost, completely unaware of our freezing doom for 8 minutes and 20 seconds. The nearest star, Proxima Centauri, sits over 4 light-years away. When we look at the Andromeda Galaxy, the nearest large spiral galaxy to our own, our telescopes capture light that began its journey 2.5 million years ago, long before modern humans even walked the Earth. We cannot see the present state of any distant object. We always, inevitably, see the past. The further away an object is, the further back in time we are actively looking. This relentless delay imposes a terrifying and beautiful geometry upon our reality. The universe, as seen from our vantage point on Earth, is constructed like a series of concentric shells in time. The closest objects exist in the most recent past, while the most distant objects reside in the most ancient past. But this journey into the dark has a strict, absolute limit. The observable universe has a fundamental boundary set entirely by 2 uncompromising factors: the speed of light and the finite age of the universe itself. The universe was born roughly 13.8 billion years ago, and light, emitted near the moment of the Big Bang, has been traveling continuously toward us ever since. This ancient light, the cosmic microwave background radiation, represents the absolute edge of human sight. It left its primordial sources about 380,000 years after the universe began, and it has been traveling through the void for over 13 billion years. It is the oldest light we can physically observe. Everything before that era is inaccessible, veiled in a hot, dense fog that light could not freely penetrate. More importantly, anything lying beyond the distance that light could have traveled in 13.8 billion years is permanently erased from our reality. The observable universe is not the entire universe. It is merely a localized sphere within which light has had enough time to reach us since the very beginning. Beyond that glowing horizon, the cosmos undoubtedly continues, vast and perhaps infinite, but we cannot see it. This blindness is not a failure of our technology. We are blind because the universe has simply not existed long enough for light to travel from those unimaginable distances to our present location. The speed of light is not just a measurement of velocity. It is a strict cosmic horizon, an absolute boundary of knowledge, and a physical limit on what the universe can possibly tell us about itself within any given span of time. Yet, for all its unyielding authority in the vacuum of space, the speed of light possesses a fascinating vulnerability when it interacts with matter. Light in a pure vacuum always moves at exactly c. That absolute speed is not negotiable. But when light travels through a physical material, it physically slows down. As an electromagnetic wave enters a pane of glass, for instance, it drops to about 200 million meters per second. In water, it moves at about 225 million meters per second. If it passes through a diamond, the dense, rigid lattice of carbon atoms drags the light down to a mere 124 million meters per second, which is less than half of its vacuum speed. This phenomenon happens because the electromagnetic wave intimately interacts with the atoms of the material it is traversing. The photons are constantly absorbed by atoms and immediately re-emitted, absorbed and re-emitted again and again in a frantic, microscopic dance. Each of these countless atomic interactions takes a tiny fraction of a second, meaning the average progress of the light pulse through the dense material is measurably slower than its pristine flight through the empty void. Physicists, driven by an insatiable curiosity to manipulate the fundamental building blocks of nature, wondered just how far this braking mechanism could be pushed. In 1999, physicist Line Howe and a team of researchers at Harvard achieved something that sounded like pure science fiction. They utilized a cloud of sodium atoms, meticulously cooled using lasers and magnetic trapping techniques to about 50 billionths of a degree above absolute zero. They then fired a pulse of light directly into this ultra-cold, quantum gas. The light did not just slow down to a fraction of its normal speed. The pulse dramatically plummeted to a mere 17 meters per second. 17 meters per second. A fast cyclist pedaling down a quiet street could comfortably keep pace with the fastest entity in the cosmos. Later, this same brilliant team pushed the boundaries of reality even further. They slowed a pulse of light down, and then they stopped it entirely. A pulse of light was literally frozen in place within the atomic cloud, its precious information perfectly transferred to and stored within the quantum state of the holding atoms. Then, by carefully reapplying the precise laser fields, they released it once more as light. It was stopped, held, and released. This breathtaking experiment does not violate any sacred principles of relativity. The individual photons, traveling in the microscopic empty spaces between the cold sodium atoms, were still fundamentally moving at c. But the experiment makes a visceral, crucial distinction incredibly clear. The speed of light inside materials is not c, and it can be manipulated, altered, and even brought to an absolute standstill. What remains eternally inviolable, what is absolutely unchangeable, is the speed of light in a true vacuum. That pure speed is permanently set by the electromagnetic properties of the vacuum itself, fixed by the deep, underlying structure of the universe. The absolute stability of this vacuum speed eventually forced humanity to rethink our entire relationship with physical measurement. For centuries, we defined our physical world using arbitrary, material anchors. The meter was once defined as a specific fraction of the distance from the North Pole to the equator. Later, it was defined by the length of a highly protected, physical metal bar kept securely in a vault in France. But physical objects are inherently flawed. They expand, they contract, they degrade over time. In 1983, the international scientific community made a profound philosophical and practical shift. They officially redefined the meter itself. The meter was formally redefined as the exact distance that light travels in a vacuum in precisely 1,299,792,458th of a second. This was a quiet but monumental revolution. We were no longer attempting to measure the speed of light using our flawed terrestrial distances. Instead, we surrendered our mathematics to the cosmos. By this official definition, the speed of light is now exactly 299,792,458 meters per second. It is no longer an approximation, and it carries absolutely no margin of uncertainty. The speed of light became the supreme anchor of our entire measurement system, simply because it is the most stable, reproducible, and universal physical constant we have access to. It is the bedrock upon which the rest of our physical reality is scaled. But when we step back and examine the full, staggering scope of this endeavor, we uncover a deep, almost haunting circularity in our quest to understand the cosmos. We desperately want to know why the speed of light is exactly what it is. We search for a deeper mathematical truth, a hidden layer of physics that explains the precise values of the constants that govern our reality. But we face a terrifying, insurmountable barrier. We cannot observe the universe from a neutral, outside perspective. We are completely trapped inside the very system we are attempting to decode. Measurement inherently requires a measuring instrument. Those instruments, whether they are massive interferometers or simple tabletop lasers, are fundamentally made of atoms. Atoms are held securely together by electromagnetic forces, and the strength and nature of those electromagnetic forces are dictated entirely by the properties of the photon, including its absolute masslessness and its rigid speed. The measuring instrument we carefully build to measure the speed of light is literally constructed of atoms whose physical properties strictly depend on the very speed of light we are actively trying to measure. There is a deep, inescapable circularity here. The speed of light is not just a passive rule. It actively shapes the universe in which we exist. It dictates the delicate spacing of our atoms, it controls the complex chemistry of our biology, and it directly engineers the physical structure of our brains. It shapes the very instruments we use to observe the universe. Therefore, it fundamentally shapes our physical ability to observe and measure the universe itself. We are not neutral, objective observers standing outside of nature, looking in through a clean window. We are direct expressions of the constants themselves. Our entire cognitive apparatus, our brains, our sensory systems, our capacity for logic, is a biological product of the specific parameters of this exact universe. This is not a paradox. It is a profound feature of a self-referential cosmos. The constants that mold the fabric of reality also mold the biological beings who eventually rise up out of the dust to measure those exact same constants. We cannot step outside of existence to ask what the universe would look like if the speed of light were completely different. We are inside what we are measuring. The way we intuitively reason about cause and effect is strictly shaped by the fact that we evolved in a universe where causality is rigidly structured by C. Our perception of time is governed by the very time dilation effects that this speed limit implies. The intricate, electrical chemistry of our neurons, which grants us the ability to think, wonder, and ask these questions at all, is entirely dependent on the fine structure constant, which is irrevocably tethered to the speed of light. The story of the speed of light is not just a dry recitation of physical constants or historical laboratory experiments. It is the story of a universe desperately trying to understand itself. From the rudimentary timing of Jupiter's moons to the freezing of light in an ultra-cold quantum cloud, every layer we have peeled back has revealed a reality more interconnected and profoundly structured than we could have ever imagined. Each generation has pushed further into the dark, realizing that the numbers we measure are not just arbitrary speeds. They are the conversion factors between space and time. They are the absolute limits of causality. They are the fragile thresholds that allow chemistry and biology to flourish. The speed of light is the grand architect of our reality, operating in the deep silence of the vacuum, holding the chaotic forces of the cosmos in perfect, terrifying balance. As we stand on this pale blue dot, looking out toward an ancient, glowing horizon we can never truly touch, we must embrace the profound beauty of our limitation. The universe is a vast, self-referential puzzle, and we are the pieces that have finally learned how to look at the board. We are the cosmos, rendering its own history, measuring its own absolute limits, and slowly coming to understand the majestic, uncompromising rules of its own existence. Good night, and see you in the next video.